First, let's see what is the importance of a decorators. Why we need a decorator? The problems can be solved in different ways. So, but what this brings to the picture. If let's say I have two functions called as division, say I have two functions like addition and subtract division. These are two functions. Now, if I define these two functions and if I want to execute, so what I can do, I can ask, hey, addition of 10, 12, 13. I define the function and I make a call. So it will work. If I go ahead, cd 0 decorators, so Python 00, so and so. So I defined the function and I'm making a call. So now the problem is that if I do addition of two numbers, I get the result. If I make a print of it, I get the result, right? So you can see that result. Similarly, for this addition function, I can pass two floating point values, say 12.3, say 13.4 or 5 or something. I created one more function. So now we see it will work. So when I did 25 also I got, this also I got. Now what is that I want to try is that this addition function, whatever you give, it is adding. What if I give like, 1 and 2, which are like two strings? Basically, it is just adding. If you, the plus operator is so beautiful that if you give two integers, it does an addition. If you give two strings, it acts as a string concatenation. So like that, it works. But if you give one of them as a different thing, means like if I give one of them as a string 12, the other one is like a 13, which is like a combination of both. Then see, it is throwing an error, right? So how to address this problem? We have a typical addition subtraction. So let me open a Jupyter notebook so that we can see the decorators flow of the same problem. I open a kernel. So here also I repeat the same thing. I have these things. I created two functions at the very first thing, and I want to make use. So we have seen till now that if I define two functions and I make a call, so for the first three things, it is working perfectly. Only for the last option, it is giving an issue. Means when one of them is a string, the other one is like a integer, because we cannot add two different data types, right? We got it. In the same fashion, let me take the concept of division. So this division function also, you see, if I give two numbers, it will give the division result. So whatever the result could be. Say I have taken two examples, assume that. I am taking division of, say, 10 by 2. Whatever the value may be, it will give the result. Similarly, if I say division of 0, 2, then also I get the result. So in both cases it works. But if I do division of, so same 10, 0, it will throw an error. So means whenever you give everything properly, it is working. But in other cases, it is throwing an error. So for 0, we have a zero division error. So for this thing, this has this problem. So without having a exception handling, we cannot address this. To address this problem in a better way, how we can do? So means when everything is good, it should work. If not, also it should work. So let me take this example. So generally we have this problem that, hey, whenever you are giving so different data types are like some other value, the issue is coming. So what I will do, instead of doing directly, I will comment it so that you will be aware. I will write that result. So try, say result is equal to, I'm assigning to some variable. So except exception as ex. So return, say ex I am doing. If there is an exception, I need to return that exception. Else, you know else case, right? Whenever the else is there, return that result whichever is happening. So this is how you have. In this case, finally is not needed. I wrote like this. In the same lines, I want to do the same thing for a division also. So here n1 and n2 are there. We need to do a division. So I address this problem now. So let me take this example now. So if I take this addition, so the addition should work for both the cases. So whenever we have different kinds of data types, in all the cases it should work perfectly. If I go with like so print of addition of 12 comma 13, or like same, so 12.3 comma 13.4, it works. Or like if we give both the things as a strings, so then also it works. So both the strings also it will work. If I have, it works. So if I execute, you can notice that. But if I have, even, sorry, I forgot to say, even if I have, so print of addition of, so one of them is a string, the other one is an integer. In that case also, it should work. So it's addition. If I execute, it should work in four cases. Earlier I didn't run that code. It is working now. So whether I give directly or indirectly, it is working. In the same fashion, division also same thing works. So whatever the earlier division we have, so means like division of 10, 20 or whatever, it will work in the both the cases. So division of say 10 comma 2, so print of division of 0 comma 2, or print of division of 10 comma 0. In all these three cases it is working. Means you are able to address one problem that you have. How you are addressing? It is one problem where instead of doing an ordinary way, as you are doing a try exception, it is handling this. So how to do the same thing? So what is the advantage of going for a decorators? How they can better address this problem? So a decorator means what? Whenever we have some code which is repeating, and if you observe carefully, so till now we know that if there is some code which is repeating, so instead of reusing, so for better reusing, so we actually write a function and do it, right? If you see the first statement in a functional programming, I told the same thing, that when we are working, so first and foremost is that if something is being repetitively used, so instead of multiple times doing again and again, so we can define and reuse that. So in the same fashion, so here if you see, the function is having some part of the code which is repeating. In both the functions, you have seen some part of the code which is repeating. And if you want to extract that common piece, that is called as a decorator. So how do you extract the common piece here? You can see that commonly both has the same thing. Maybe, right, I will write a common function. So something like a common, or like you can think what we are handling here, exception handling, right? Maybe, right, I will write exception handling. In both the cases, we are doing exception handling. So this is the function. In both cases, it is taking two arguments, right? Argument 1, argument 2. If you are given two arguments, you are doing processing. So whatsoever. If you can observe carefully, so the result would be the same. Whatever the operation is there. Means, so here either addition or division. So whatsoever you are doing, right? So that you want to do. Means some function that you want to do with these arguments. Argument 1 or like argument 2. So whatever the function is there, that should be done. So here, how to pass a function to an argument as a function to another function? So we don't know. But somehow by seeing this code, we created. Means you extracted the common piece. Then what is the remaining code here? So in this, both the addition and subtraction, if I remove the try exceptions, then what will I have? Typically a comma b and return of a plus b. And typically, so division of say number 1 comma number 2, we have written number 1 divided by number 2. So this is what I have, right? So means the common code I placed here and I want to execute. How do I execute? Now you need to understand a different structure. With an ordinary function, how do you pass? So we cannot pass. Maybe like I am thinking that, okay, you can pass the function as one argument and the remaining as two arguments. Think like this. So now you see, I defined. Now we see I defined these two functions and this thing. Means instead of you executing directly, you execute indirectly. Generally, in this case also, if I do 12 comma, so 13 like this, because I modified now the addition, so to not handle exceptions on its own, if I do, it will throw an error. But how I am handling it? I am passing whatever the function to pass to it. The exception handling, for that addition I pass, and for that 12 and this 13 I pass as a string. Now did you see? It did an exception handling. So you are passing your function as one argument and you are doing. So that is why it is happening like this. So what we learned here is that, so whenever we have a function, we can pass that as an argument and do. But just imagine, so every time if you are making function also as an argument, then people will be confused. Every time people need to use this one. So which is like crazy. So to avoid that, so they told like, let's do the same try exception, but in a slightly better way. So the better strategy is like this. Whenever you are doing, so define the exception handling. What are the function you have? But the function you pass as an argument. Means instead of directly doing, you pass it as a one function, and within that define another, say inner function. For that inner function, pass these arguments and you move it. You see it, and you are finally returning it, returning the inner function. Observe carefully, earlier I passed a function also as one of the argument, but this time I'm modifying and I'm making like this, exception handling as a function like this. So this concept is called as a decorator. This is called as a decorator. So what is this decorator, sir? So initially in one of the interviews, I still remember. So when someone said like, what is a decorator? So I said like, it is for decorating. So still, so though it is funny, but it actually works like that. To help you understand what it actually does. Earlier you passed your function also as an argument to it. Now you will do slightly different. What you will do, again, if you do like ordinary 12 plus 35, so 13 like this, it will throw an error that we already know. Unlike the other earlier case, what we will do is that you pass your function as an argument to it. Means, so whatever the function is there, that function you pass as an argument. So with your call, so means like, sorry, you pass your function as an argument. Yeah, sorry. Yeah, you pass as an argument. So then like, then it will get the value. Then we can use it. If I execute right now, you see it is working. It's very simple for you to understand. So whatever I wrote, now I can generically use. So observe carefully. What I told is that you create a exception handler. So exception handling, whichever the addition or subtraction or whatever you have, that you pass to it. So ordinary, instead of ordinary addition so and so, addition exception handled, something exception handle is equal to. So this exception handling of, so add. If you give directly to the add, it will throw an error if there is an issue. But this one, will not throw any error. So if you pass in either way. So if you observe what is this value, it is again a function, right? If you can observe carefully. So it is a function again. So don't you think like what you have learned earlier, like a closure? So now the point is, for this new function which I created, I can pass the inputs. If I pass 12 comma 13 as a string, like that also it will work. So if I do everything correctly also it works. So let me give like a single quotes as it is within it. So if I do like that or everything correctly, so or if make one of them as a float, so different edge cases. In all the cases it's working. Unlike an ordinary addition, so we are able to do in the same fashion for division. So you know the division function. So for the division function also we can do the same thing. So we have the same logic. So just I am repeating such that we can better use. So we have the division function. So we already know, but still I am writing. So div of like n1 comma n2. So return n1 divided by n2. I have two functions like this now. Now see what I will do. If I directly execute a div of 10 comma 0, it will throw an error. That's for sure. So instead of that, what I will do, so div exception handled something, I create a new one. Exception handled is equal to, so exception handling of your div function. So you do, and for that resultant new function which we created, you pass whatever values. If I pass now div function of 10 by 2, traditionally it works. If I do like a 10 by 5, that also works. If I do like so 0 by 5, that also works. But if I say the same 10 by 0, so that also should work as per the need. You see now, in all the cases it worked. So what we are doing, we are empowering the ordinary functions with the extra functionality. If you have any extra functionality, we can do like this. But don't you think that every time whoever is using your div function need to know how to do exception handling? If they assume that there are different tasks, they cannot go for everything, right? So for that, there came a concept called as syntactic sugar decorator. So in the decorators concept, there is something called as syntactic sugar. Means like, so okay, whenever you are using, you are writing, right? Every time, like this decoration. Instead of that, you do only once. So instead of doing all the times, one second. Once. So in this process, what happened? Whenever you are doing, whenever you're consuming anything, so every time before consuming your function, you need to create a pseudo function. Means for every function, we need to write one more extra. So how to address this problem? So instead of solving like this, so we can do in a better strategy. Means every time the consumer should know which function to use. So whether to use this add function or this modified add. This is a difficult, right? To avoid that, what they recommended is, hey, so you define your functions. You have your addition, right? say addition of so a comma b, return a plus b. Similarly, we have division of so number 1 comma number 2, return number 1 slash number 2. So this is what the function you have. Now, instead of you creating a pseudo function every time, so rather than that, you delete and take this as a decorator on top. Means at the rate decorator. At the rate is a symbol newly. So on top of every function, you need to register. The moment you register this function, so then things works better. If you see now in together, if I ask, so both kinds of things together, say like I am asking now all 4 kinds of executions. In addition also all 4 types, division also 3 types. If you execute now, did you see in one shot all were working? Whether there is an exception or not? So that's a point. So if I don't write this thing, then they were like ordinary functions. They are prone to exceptions. But if I define them, if I execute, they will execute. Now, not only for addition or subtraction, I can solve this problem for multiple things. Now let's take, I'm doing for another function called as multiply. Multiply. This time I'm taking 3 numbers, n1, n2, n3, and I'm multiplying all the 3 values, n1 into n2 into n3. This is an ordinary function. So obviously when I execute, if I say like multiply of say multiply of 1 comma 2 comma 3, it works perfectly. But so if I do like one of them is a string, then what happens? For the first one, it will work. For the second one also, it is working. Yeah. In the second case also, it's working. And you know, the point is like in Python, we have the string concatenation operation, which will work, right? Whenever you give one of them as a string, so then obviously it will take that one as a string and perform. So due to that, you are seeing. So when you give 3 as integers, you got like 6. But if you give one of them as a string, the first 2 are multiplied, so it becomes 3. 3 into 3 as a string. So like that you got. So now, but if I go for the third one, if I say a multiply of one of them as an integer, the other one is a float, so other one is like a string again, the third one. Now in this case, it throws an error. But can I do like the @ symbol such that the problem can be solved? Let me give it a try. So we know that exception handling is the decorator we created. Exception handling I wrote. So now I want to address all the 3 problems. So it should work for all 3, right? I executed. But I got another error. So even ignoring this, the last one, even for genuine ones also not working. What is the issue? If you can observe carefully, this inner function, exception handling dot dot inner, is taking like 2 arguments, but 3 were given. If you go in detail into the exception handling, what you have defined in the top, did you observe that it is taking 2 arguments, but it is taking 2 arguments only? But our function requires 3 arguments. Then how to handle it? So when you want to have 2 arguments also it should work, 3 arguments also it should work. So to handle that, we need to go with the generic way. So we should say like, star args means any number of args, and also star KW args. Means either user gives like direct arguments or like keyword arguments, any number of arguments they can give. So that should be passed. If I do this one change, then it becomes a very generic. The first one takes a function, second one takes the arguments. You need to pass like that. Now we see, so the genuine cases and all these cases together will work. I modified our function in such a way now. I wrote the exception handling on top. So now I need to handle all these three cases. I will take them to one place. So I will make one of them as floating point value. So you see now, did you see all the three cases were addressed? At the same time, the earlier cases also should work, right? The addition, subtraction, and others. Yeah, for them also we have an exception handling. Those also should work. So those also will work perfectly. Means 2 arguments also working, 3 arguments also working. So now if you write a generic function like this, it can be handled for different edge cases. So one more thing. So if I can create some kind of a function which will do retry. If you are given one function, that function should execute for n number of times. So for that, let's create a retry decorator. So decorator for retry or retry decorator I want to write. So how to do? So any function, if you are given, so it should say like those many times it should run. So we have a function and I'm making a call like hello world of say Python. If you see one time it is executing. But if you want this function to execute for 5 times, so for I in range of 5, you run the call the function, right? So rather you can write a decorator which can do it. So when you're writing a decorator, so you need to be aware. So retry, which is taking a function, and we need to pass a inner function. So this is what we did. I think I'll leave it. Now I need to create a decorator for the retries. How to do? The generic structure is the same way. For retries, if I want to do, so star args, star kw args, means like in a generic fashion. If you are given any function, I need to execute for them that number of times. For assume that we want to execute every time for 5 times for whatever you was given. Now what I will do? So for 5 times, I need to execute this function. So which are the function which was passed? Function of star args, star kw args. Now you see the function was executed that many number of times. And for every decorator, the structure is like that. So first we need to define an outer function, which takes function as an argument. So then there is an inner function, which take arguments. And we need to return the inner function to the outside world. Now, the same function, if I define and I make a call. So how I do? On top, I write like retry. That's it. If I make a retry and I call it for 1 time, did you see the same function is executed 5 times? So because like you use the retry mechanism, the same thing will execute. Similarly, for your addition, say like define, so addition of. Now I need not worry. So how many arguments I am doing, what all things I am doing. So n1, n2, if I have 2 arguments. So I need to return n1 plus n2, or like it will print the n1 and plus n2. So I can do a retry to get it. Retry. So if I do now, and if I call like addition of, so 10 comma 20, if I execute, the function will be executed for that much times, but you cannot see the output, right? So maybe like you can write, say result is equal to some result, and you can print that result f of result If I execute now, did you see the same executed those many number of times? But fine, sir. So any function, if you want to retry, we can retry that much times. So what if you want a function to be retried for n number of times? Maybe you have two functions. One function you want to retry for 2 times. One function you want to retry for 10 times. But in that case, this will not work, right? So still now we have defined a function, but which will not take any arguments. But if you want to modify like that, then slightly I will modify it. So the retry mechanism in this case will not take any arguments. How many times to retry? If this 5, if you want to pass as an argument, how do you pass? If you pass an argument to your function, that will go to your function. But how do you pass an argument to your decorators? Means I want to make like 5. Instead of the 5 here, I want to say like number of times here. Then in that case, observe carefully, you need to do one more level. Means within that, so another wrapper. So wrapper, this function you need to pass to that wrapper. Observe carefully what I'm doing. Say a function within this. So number of times. What are the number of times you want to take, that you take, so that you pass as an argument to it and you execute within it. Means you are moving everything one level below, and this number of times you are passing to this. So we need to return the inner function. At the same time, this wrapper function also we need to return. So now in this case, if you observe, this will execute for 5 times, means it will execute for 5 times. And similarly, if you want to execute for 2 times, it will execute for 2 times only. Means till now you created a decorators, but not with arguments. But if you want to pass an argument, you need to do like one level above. Means 2 inner functions. I can give any name to that for that matter. So, but like if I give one name, so it will work like that. So this is how. So not only this, sometimes retry only when there is a failure. So like that, we can have different educations. So we can do differently. Or let me give you one more simple example. Let's take another example. If you take this example, say I have 2 functions. If you observe, there is an addition and multiplication. 2 things are there. In both the functions, we have print function. So print means before and after the executions, we have print statements. So if you want to execute, say I did like addition and multiplication. Observe carefully. So before, in the starting, it will print. Before executing, it will print. You get the result. So starting and before exiting, it is doing a print. Then in this case, how do you create a decorator? So for this, what is that you are doing? Printing, right? I can say like a print function. Something like a print function is my decorator. I don't need any arguments. So I can directly write a function. And within that, there should be an inner function. You give any name. I just write inner because it makes no sense. So just it's a common thing. But you can write any name as you wish, because anyhow, no one will call that with a name, right? You can call anything. So within that function, so what are the function you gave? That function we need to execute. Args, and star kwr. So this is something which is common. In both the functions, we have like before and after you are printing. I am taking that common thing. So before execution, I am printing. And after execution also I am printing. And this intermediate result also I am taking. So result is equal to what are the function execution result? I place it. After that also I do. And finally, I return that result. So I took the common part in both. As I took common part, so of course, I don't forget to return the inner function. That is most important. After executing like this, so now what I can do, as common part I took, I can write the same functions again. I can make it like a decorator here. print function, and I don't need this both executions, right? It need to do direct execution like this. I am saying that. Similarly, here also I am removing the print statements before and after. I am getting it. So if you want directly also you can assign, or indirectly also. Now if you see before and after execution, in both the cases you are seeing the result, both for addition and this one. So for both the functions you can see the same thing, before and after executions. So but this is coming only for one, because for only one you made a decorator. For the second one also, if you make a decorator, now you see for both things happen. So like this, you have one function, you did it. But sir, can you mature it? Means when you are starting, which function is started, which function is ended, that if you want to know, we can slightly mature it. Means instead of doing directly that function started, I can do something like this function that you pass having an attribute of name, that I can use. So, and similarly, this function which is ending, for that also I can take an argument and use it. Now, together if I use, did you see? Addition function started, addition function ending. Multiplication function started, multiplication before end. Now, don't you think it's much better? So this is like one use case. So another use case, if I think, so it means like time taken. Generally, if you want to calculate the time taken by anything, so we generally take the time module. So using the time module, so we use something called as a counter. So next you will learn about the time module. There will be some start time is equal to some counter. And if you have some logic within it, say I will write the logic, means from this start, it will take a start. So then from there, it will execute the logic. And after the execution, we need to calculate the end time. So for that, there are two ways. So you create the end counter and you make a start time minus end time. If you execute, totally how many nanoseconds were done, it will tell that. Or else, instead of assigning to a different variable, so we can directly do it. Means, instead of assigning to another variable and doing this thing, so we can directly take one more counter return value minus start. So both ways we can do. See, from coming till here to here also, it is taking some more nanoseconds. That's where the difference you can notice. So like that, we can use for the counter. For any function, if you want to know how much time it is executing, so traditionally what we do is that you take this function. So you use this logic, like start. If let's say I have one function, I want to know how much time it is executing. So first, before starting, I write it. And at the end of the function, I calculate the total time. So time, how much time it is taken. So I am executing. So this is how traditionally I do it. So it is telling that these many nanoseconds were done. But you know, if you want to create a decorator, how we do? Define time taken. Time taken is a decorator. So every decorator takes first argument as a function. So within that we have a inner function, star args, star kw args. So within that write something and return the inner function. So this is the first and foremost basic syntax of any decorator. And within that, we need to run your logic. What are the function is there and what are the arguments you have? Both we need to execute. So now what they are saying, before starting execution, they are taking the counter. So before executing, I take the initial start time. So, and I need to return the result. So I need to take the result. And finally, after execution, I want to print what is the total time taken. And finally, I need to return the result. So this is how I created a one decorator. Now say this function, I want to use it. So how I can use it? Observe. On top, I need to write like time taken. So I don't want this start one. So end also. I can focus on what is my logic. Or similarly, if I have one more function, so I can do the same thing there too. Say like I have one more function. For that function also I did. So for both functions, f1 and f2, I'm asking. Observe carefully. So I wrote a decorator. So for any function, it will take the total time taken and it will give it. So, and now it works in such a way that if I execute, it will give. For the first function, it took this much nanoseconds. Second function, it took more nanoseconds. Means if you are popping the last value, it will take less time compared to popping the 0th value. So this is one thing I understood. But if I want to further mature it, so I can do like, so how much time it has taken? Instead of just telling like that, I can write like, okay, so time taken is, so in a beautiful way, I'm writing. So for the first one, it took this much times. For second one, it took this much nanoseconds, I can write. Or like for a function name also I can write if you want. So you can write the function name too. So for say func dot underscore name underscore. If I give for that function, how much time it took? Now you see it is much more smarter. For this function, it took this much time. For this function, for total, it took this much time. And similarly, you have created multiple decorators. Say assume that we have like multiple decorators. Say like I created one decorator. Say one decorator like this. This is one decorator, which has a wrapper, means that I can write inner function any name. I'm saying I'm a decorator, I'm executing this function. Similarly, I have one more function. So it means one more decorator I am writing. It makes no sense, just I'm writing some dummy decorators. Similarly, I will make one more decorator. Means totally I have 3 decorators. So what is it doing? It does nothing. Yes, I have 3 decorators. So, and now I have one function. For that function, I can apply these 3 decorators at one shot. If you want to apply, we can apply multiple decorators also at one shot. How the execution happens, sir, in the backend? So you can understand. If the order in which you gave is a number, so decorator function 3, so then decorator function 2, then decorator function 1 means first it will go to decorator function 3. Then it will do the decorator function 2, means in the top to bottom order. So execution decorators will go in a top to bottom order. So top to bottom and left to right, right? So whenever you have like multiple decorators, it will work. In the same fashion, so just now we have seen 2 decorators. One is our time taken and print function. If I have both the things, so if I want to execute, I can say that I will write a function. So now you see here, both time taken also I'm writing, print function also I'm asking. Now, if I make a call to one of the function, so now you observe, that's a beauty. So this common logics I can place separately and I can just use it. So in print also it is giving, time taken also it is giving. So if I do like for multiple functions also, it will execute and help me. So now you see, I can focus on my own logic instead of the common repetitive logic. So this is the decorators. So in this way, we can work on decorators. So down the line, so we have seen decorators like a thing like this.